At 0530 local time, 3 Ukrainian Sea Baby drones that had been running dark for 90 minutes as they headed towards a Russian-controlled oil platform turned surveillance outpost, completely unaware that a Russian Ka-52 Alligator had just picked them up on patrol 8 kilometers away. In exactly 30 minutes, what began as a routine drone strike would turn into one of the most devastating attacks on Russian Black Sea infrastructure. The Russian Ka-52 Alligator banked hard and dove through morning clouds, catching his first glimpse of the targets at 8 kilometers. 3 gray shapes cutting white wakes across black water. No identified friend or foe response showing a friendly Russian frequency. No recognized profile in its recognition charts. These were unknown vessels approaching Russian-occupied waters at attack speed. The pilot rolled the Alligator hard left, collective down, nose over. The helicopter dropped from 600 meters to 80 in under 30 seconds, speeding past 260 kilometers per hour. The gunner swung his targeting camera onto the drones and zoomed in for a tighter shot. The Sea Baby formation held a tight column, 30 meters between holes, to minimize detection and simplify navigation. The pilot pushed lower, down to 40 meters altitude, trading altitude for weapons accuracy. At that height, he felt faster than he was, closing at a combined speed that turned the engagement into a knife fight. He rolled the pylon switch to cannon, armed the Shipanov 30mm you see here, and lined up his run. The plan was simple: 1 pass, 1 long burst, 3 drones, and back to patrol. He'd done it before, but this time was different. The gunner thumbed the trigger. The Alligator's nose yawed slightly as the cannon spooled up, hurling a stream of 30mm high explosive incendiary rounds ahead of the helicopter. Tracers walked downrange in a straight line, slamming into the water with geysers of spray. On the drone's cameras, the ocean turned into a forest of vertical white spikes. The lead operator threw his control stick left, then right, then hard left again, breaking the formation, forcing the cannon to chase 3 diverging paths instead of 1 simple column. The Ka-52 systems were built to track tanks, not jet skis with bombs. The Shkval had no trouble locking onto a T-72 turret at 8 kilometers because the tank gives the software something solid to grab: sharp corners, heavy shadows, big metal surfaces the computer can match from frame to frame. That's how the auto tracker keeps its crosshair glued to a target. A Sea Baby at 2 kilometers gave it none of that. It filled only a few pixels on the screen, just a small shape bouncing on top of relentless water. Every time the system tried to follow the bow, white spray from the wake washed out the image and broke the lock. The gunner had to ride the sight manually, nudging his thumb controller to keep the crosshair on a target that jinked 10 degrees off course every few seconds. At 260 kilometers per hour, a 1-degree error meant missing by tens of meters. His Arbalete 52 radar wasn't much help. It was built to track aircraft and large vehicles, not a tiny hull buried in wave reflections. Near the surface, the radar picture collapsed into scattered flashes of sea return. Too much noise, not enough target. The radar confirmed that something was there, 3 somethings at 4.5 kilometers, but couldn't give a fire control quality solution on any of them. The gunner had eyes and guesswork. The drones had numbers and time. He tightened his burst, shortening it to controlled 2-second pulls to conserve ammunition and keep recoil manageable. Round stitched closer. The pilot pulled up to reset. He leveled off for a moment, giving the gunner a steadier platform and buying himself a few seconds of breathing room. This shouldn't be happening. The Ka-52 wasn't just another Russian helicopter. The Ka-52 was built to dominate ground armor, not play whack-a-mole with sea-skimming drones. Its strength came from brute mechanical muscle, 4,800 combined horsepower driving twin coaxial rotors that let it knife through turns tighter than most NATO helicopters could manage. Its flight computer stabilized those counter-rotating blades with a digital autopilot that could hold a hover in 40-knot winds and keep the nose glued to a tank column even while the pilot yanked the collective around. But all that power came with assumptions about the battlefield. The Ka-52's fire control brain was tuned for targets and thermal mass, angular geometry, and predictable movement, the kind of signatures tanks, APCs, and infantry fighting vehicles produce without trying. The Sea Babies had none of that. The drone's electric motors barely warmed above the surrounding water, giving the Ka-2 almost nothing to track in infrared. And their low silhouette, just 40 to 50 centimeters above the surface, put them inside the helicopter's worst engagement geometry. And that was the problem. Every system on the Ka-52 was optimized for big targets with mass and heat, not something that barely showed up on its sensors. Each Sea Baby you see here was about 5.5 meters long, built from a hard chined fiberglass hull with a radar cross-section scarcely bigger than drifting debris. With a draft of less than half a meter, most of its body sat inside the layer of wave clutter that maritime radars struggle to see into. Two 70 to 80 kilowatt electric motors drove a ducted propulsor that kept them quiet and fast, 35 to 40 knots on a sprint, without throwing a heat plume into the air. Their compact navigation mast held a dual-band line-of-sight antenna, a front EO/IR camera, and a GLONASS GPS receiver tied to a ring laser inertial navigation unit that tracked rotation down to 0.001 degrees. Even under heavy jamming, the onboard computer could hold a heading with impressive precision, and under the deck sat a sealed internal module with its own power bus, something the helicopter crew couldn't see and couldn't account for, but something that would make defending the platform far harder than the Russians realized. All three drones were still moving east. Now the Ka-52 needed more than a gun run to stop them, as they were quickly leaving his cannon's engagement envelope. He had to bring out the big guns now. He climbed to 200 meters, rolling into a wider arc to set up missile geometry. The gunner switched the weapons panel to Vickers-1, the beam-riding anti-armor missile that could just as easily shred a fast boat if it could maintain line of sight. On paper, the missile didn't care whether the target had tracks, wheels, or a propeller. In practice, the engagement envelope assumed something bigger than a fiberglass robot. The Shkval crosshair found the lead Sea Baby again. The gunner heard the steady tone in its headset, felt the aircraft settle as the pilot gave him as smooth a platform as possible. Range, 3.2 kilometers. Closing speed, just under 100 meters per second combined. That gave them barely 30 seconds between launch and overflight. Enough on a test range, not much over gray water with a target that treated a straight line as a suggestion. He squeezed the launch trigger. The Vickers dropped from the rail, motor firing a second later. From the drone operator's perspective, it looked like a bright point accelerating across the sky, drawing a ruler straight line toward their hull. The Sea Baby's evasion routine wasn't random. In training, operators had learned what sometimes broke laser-guided weapons: short, sudden course changes at irregular intervals. Never the same timing twice, just enough to drag the aim point off a hull that barely existed in the sensor's world to begin with. The Vickers tried to ride the laser cage, a narrow box of laser light the missile uses to guide itself to the target. On calm terrain, it works. On open water, the beam jumps with every swell. The missile passed within a few meters of the Sea Baby, close enough to throw spray across its deck, then detonated in open water. The shockwave rocked the drone, but its hull and internal mounting tolerated more damage than its shape suggested. The formation had scattered under fire, but all three hulls were still moving east. The gunner's display filled with blooming heat and foam from the miss. For a moment, all three contacts were lost in the flare. When the sensors cleared, he saw the Sea Baby spread wider than before, each on its own path, all still converging on the same general bearing toward the Russian oil platform. He checked remaining missiles, checked ammunition, and checked fuel. They couldn't stay any longer. They needed to head out now or they were swimming home. He keyed the radio, tasting defeat. Sevastopol Control, Pelican 4. 3 surface contacts still active, continuing southeast at 40 knots. Position 35 kilometers northwest of Savash, unable to prosecute further, returning to base. The response crackled with barely concealed frustration. Understood, Pelican 4, passing to Savash. They'll be ready. The 3 Sea Babies leveled back into a loose line abreast and kept running dark across the western Black Sea. In less than half an hour, those same gray hulls would be closing in on the platform. But the Russians were now ready. As the drones closed with the platform, their operators couldn't see it, but the Russians had jury-rigged an electronic warfare suite to the platform to give it the semblance of protection against drones. The only problem is this system was about as useful as an umbrella in a swimming pool. The platform's Pole 21 system wasn't much to look at. 4 antenna modules mounted on the platform's legs, each no bigger than a shoebox, connected to a control unit in the equipment room that looked like a 1990s server rack. Allegedly, the Pole 21 could deny GPS navigation for 25 kilometers in every direction, forcing anything relying on satellites to go blind. In theory, this should stop GPS-guided drones in their tracks. In theory. The EW operator had been monitoring his screens for 6 hours straight when he watched his spectrum analyzer as the Sea Babies approached at 15 kilometers. The Pole 21 was already broadcasting 100 watts of noise centered on the GPS bands, power enough to drown out satellite signals that arrived at negative 160 dBW. Whispers from space competing with a bullhorn. His display showed the jamming bubble, a perfect green circle on the map. Anything inside should be navigationally helpless. Right on schedule, the lead Sea Baby's GPS receiver flickered off at 14 kilometers. 9 satellite contacts vanished from the operator's screen back in Odessa. But in that final second before signal loss, the drone's computer grabbed one last position fix. This became the 0 point for everything that followed. The drone didn't stop, didn't circle. It kept coming. Now the Sea Baby was navigating like sailors did before satellites. Dead reckoning from a known position. 3 ring laser gyroscopes, each the size of a hockey puck, tracked every rotation down to 0.001 degrees. The onboard computer did the math 30 times per second. Started here, moved this direction at this speed for this long, therefore now here. The operator in Odessa watched his navigation display change. The solid green line showing GPS track turned into a dotted yellow estimate. Numbers in the corner showed accumulated error. 10 meters after 1 minute, 25 meters after 2 minutes. By the time they'd reached the platform, dead reckoning, an old navigation method that estimates location by combining heading, speed, and time instead of using satellites would be off by maybe 150 meters. Except the platform was 100 meters wide and lit up like Vegas, close enough for government work, but they weren't relying on dead reckoning alone. That would be stupid. The Sea Baby's receiver could also monitor GLONASS, Russia's own GPS system. On frequencies the Pole 21 wasn't touching, 1602 MHz and 1246 MHz. Jamming those would blind every Russian unit within 25 meters, including the platform's own helicopters. The GLONASS signal was weaker, only 4 satellites visible instead of GPS's 9. Position accuracy degraded to 20 meters instead of 2. But 20 meters was better than accumulating error. The operator's screen showed both tracks, the yellow dotted line of dead reckoning and a fuzzy red line from GLONASS. When they diverged more than 50 meters, he trusted GLONASS. When GLONASS dropped to 3 satellites and lost position, he trusted dead reckoning. Together, they kept him on target. The Russian EW operator leaned forward, confusion replacing confidence. His jamming was perfect. Total GPS denial verified across all L-band frequencies. Yet the radar track showed 3 contacts maintaining course, speed never wavering. They should be lost, should be circling, should be dead in the water. What he didn't know was that at 8 kilometers, everything changed again. The lead Sea Baby's camera could now see the platform clearly in the morning light. The operator in Odessa switched to visual navigation, using the platform itself as a reference point. The navigation lights, red on port, green on starboard, white floods on the helipad, gave him orientation. The radar mast provided altitude reference. The camera's field of view was 68 degrees horizontal. The platform filled 12 degrees of that at 8 kilometers, growing larger every second, like judging distance to a car by how much of your windshield it fills. Meanwhile, the Pole 21 was cooking itself to oblivion. Salt air had been eating the amplifier since installation day. The cooling fans were clogged with crystallized salt that formed faster than anyone could clean it. The system's temperature had climbed past 70 degrees Celsius, past 75, now past 75. At 80, the thermal protection should have kicked in, but the operator had disabled it. Orders from above: maintain jamming no matter what. At 82 degrees, things got interesting in the worst way possible. The number 3 amplifier didn't fail gracefully. It went out kicking and screaming, sending 300 volts through circuits designed for 50. The surge protection fired, saving other units, but 1/4 of the jamming power vanished instantly. The coverage pattern warped from a circle to a 3-leaf clover. By accident or Ukrainian intelligence, the Sea Babies were approaching through the gap between the leaves, where jamming power dropped by 15 dB, the difference between a shout and a whisper. This was the moment the trailing Sea Babies chose to reveal their surprise. Pneumatic tubes popped open. 8 FPV racing drones launched into the morning air, props already spinning. These didn't need GPS, GLONASS, or any satellites. They navigated purely by video feed, the operators seeing what the drone saw, flying it like a video game toward the massive platform that filled their cameras. The Pole 21 might as well have been jamming smoke signals. The Russian operator watched 8 new contacts appear on his screen, climbing away from the sea surface. He knew exactly what they were, knew the Pole 21 couldn't stop them. The PKM gunners on deck were about to earn their combat pay the hard way. The Special Forces sergeant manning the North Tower PKM had plenty of experience with them, seen drone attacks before, but those were commercial quadcopters dropping hand grenades. These moved different, purposeful, like they knew exactly where the soft spots were. He traversed the PKM and opened fire at 500 meters. The mathematics of hitting a racing drone was not much better than the odds that an email from a Nigerian prince is real, but that didn't stop him from trying. The gun chewed through his 200-round belt in 18 seconds. The barrel glowed cherry red. After 600 continuous rounds, the rifling starts melting. Accuracy goes from maybe to forget it. Before they could even get that far, the drones were already splitting like a car dealer's shuffle. 3 at 200 meters, 2 low, below the platform deck level, 3 more baiting the gunners at deck level. Every gunner picked their own target, creating a light show of tracers that would have been beautiful if it wasn't so useless. The FPVs flew through unfazed. The first racing quad found the FERC-2 radar array. Its 300 grams of RDX turned the dish into abstract art. 3 million rubles of precision electronics crumpled like a soda can. The second MPV slammed into the satellite uplink dish, cutting the platform's primary communication to Sevastopol. The third found a PKM position, the explosion small but enough to destroy it. 2 more hit the crew quarters windows in sequence, starting fires that would burn uncontrolled. They were small explosions, but everywhere at once. They were keeping every defender busy with their own problems. Through all this chaos, the lead Sea Baby kept coming. It plowed into one of the support stanchions at 35 knots. The explosion was massive, 2,000 kilograms of RDX detonating against steel. The entire platform shuddered, but when the smoke cleared, the leg was still standing. They still needed a second Sea Baby to finish it. Then, just as the second Sea Baby closed to 200 meters, an RPG team got position. The shooter shouldered an RPG-7. The optical sight found center mass, a gray rectangle bouncing through swells. Breathe, hold, squeeze. Whoosh! The rocket accelerated to 300 meters per second. The PG-7VL warhead could punch through 500 millimeters of armor, should turn a fiberglass drone into confetti. The shape charge detonated against the water a few meters from the Sea Baby's starboard side. When it cleared, everyone expected to see debris. The drone was still there, still moving, listing badly, deck awash, crawling at 2 knots, but moving. Here is what the Russians didn't know. Ukrainian engineers had learned from every previous failure. Every drone that almost made it taught them something. The warhead, 2,000 kilograms of military-grade RDX, enough to turn a city block into a memory, sat in a steel tube below the waterline. Many millimeters of AR-500 armor plate around it. The hull above was sacrificial. 5 watertight compartments with crumple zones between them. The RPG had done exactly what it was supposed to do. Punched through the outer hull, flooded one compartment, knocked out the main motor. The drone looked done for. But the backup motor, a washing machine unit in the stern with its own battery, kept turning. 2 knots, walking speed, didn't matter. The finish line was 50 meters away. The Russians threw everything at it. PKM rounds hit the water around it. AK-74 rifles joined in. their 5.45mm bullets as useful as spitballs against steel designed for shaped charges. Another RPG went wide, the shooter rushing, scared, hands shaking, detonating well ahead of the drone. The Sea Baby crawled forward. Its cracked camera showed the platform growing larger. The operator held course using the platform's own navigation lights as a reference. Then, contact. The explosion lifted the platform's northwest corner 6 inches. 2,000 kilograms of RDX in direct contact with the support stanchion. The steel leg, 20 inches in diameter, rated for 10,000 tons vertical load, folded like a wet paper bag. The platform immediately listed 8 degrees, then 10. Alarms shrieked in frequencies that bypassed your ears and went straight to your spine. Soviet engineers in 1987 had designed these platforms to survive single-point failure. One bomb, one accident, one bad day. Their computers, running Fortran on processors weaker than a modern calculator, never modeled coordinated attacks on multiple load-bearing members. The K-braces between legs, meant to share weight like good communists, now shared destruction. They transmitted forces the structure was never meant to handle, turning localized damage into systematic failure. 15 degrees list. 18. 20. The center of gravity, normally centered between 4 legs like a table, shifted past the tipping point. The ballast system, capable of handling 5 degrees by pumping water between tanks, screamed pump alarms as it tried to fight physics. Physics won. And somewhere in Moscow, generals would stare at satellite photos of their unsinkable platform, now a navigation hazard, wondering how they'd lost the Black Sea to a nation that doesn't have a navy. Bye for now.